Today, lesson 27A. It's day number 2 of solving one-step inequalities. Last lesson, we discussed how to solve one-step inequalities where you had to add the same number to both sides or subtract the same number from both sides. We continued with the idea that we would graph our solution because the graph represents all of the possible solutions that can happen for each inequality. Well, today, we cover the other half of that, which is solving and graphing one-step inequalities using multiplication or division. We'll also spend a little bit of time writing inequalities from word phrases. So, in your notes, we have this chart right here. And what we're going to do is we're going to start with this inequality right here. 4 is less than 6. And we're going to do some things to that inequality. First of all, is the statement 4 is less than 6? Is that a true statement or a false statement? True. It's a true statement, right? 4 is less than 6. So we're starting with the true statement, and then we're going to do some things to it, and we're going to try and figure out whether that ends up giving us a true or a false statement. So each one of your spaces in this column starts with 4 is less than 6 already. Okay? So here's what we're going to do. We're going to take that and we're going to add 4 to both sides of it. Now the question is that still a true statement or is it now a false statement? Is it true or false? True. It's true because now we have 8 on the left-hand side and 10 on the right-hand side. 8 is still less than 10. That's a true statement. All right, number 2. Once again, we're starting with 4 is less than 6. So I'm going to add negative 4 to both sides. Another way of thinking about that would be maybe subtracting 4 from both sides. So now on the left-hand side I have 0 because negative 4 plus 4 is 0. And on the right-hand side I have 2. Is 0 less than 2? Is that a true statement or a false statement? True. Still a true statement. Okay? All right, number 3. I'm going to start with this, and subtracting 10 from both sides or adding negative 10 to both sides is the same thing. And what we're trying to figure out here is whether that is still a true statement or if it is a false statement. Well, on the left-hand side, we have negative 6 because negative 10 plus 4 is negative 6, and on the right-hand side we have negative 4. Is that a true statement or a false statement? True. Think about a number line. It's still a true statement. Still a true statement. Negative 6 is less than negative 4. All right, let's start with 4 is less than 6. And let's multiply both sides by 4. True statement still or now a false statement? True. It's true. 16 is less than 24. Let's now take 4 is less than 6 and divide both sides by 2. Is it still a true statement or is it now a false statement? Which one? True. It's true. 2 is less than 3. All right, so far every single thing that we've done to that true inequality, 4 less than 6, we still end up with a true statement. Okay? Start with 4 is less than 6, and let's multiply both sides by negative 3. And I'm going to stop for a second. So I had you shoulder partner that one, and overwhelmingly I heard false. And the reason is because negative 3 times 4 is negative 12. 6 times negative 3 is negative 18. Negative 12 is not less than negative 18. It's greater than negative 18. All right, let's do the same thing in number 7. Let's start with 4 is less than 6, and let's divide both sides by negative 2. Figure that out on your own, and then I'll have you quickly shoulder partner what you've come up with there. So now we end up with negative 2 is less than negative 3. That is a false statement. It's a false statement. So what in the world is going on here? Well, what these last two sort of lead us to is it leads us to the conclusion that anytime we multiply by a negative number or divide by a negative number in terms of solving inequalities, we would end up with a false statement unless we flip the inequality symbol to make it true. So once again, it leads us to this conclusion right here. One of the most important rules when we're solving inequalities. And here's what I want you to do. All of the words in that statement that are capitalized, would you circle them, please? Anytime you multiply or divide by a negative number, you must flip the inequality symbol. Anytime you multiply or divide by a negative number, you must flip the inequality symbol. And right now I'm going to do two quick problems to prove to you that that's what you need to do. So here we have a statement. Is this statement true or false? True. It's true. Now, I'm going to multiply both sides by a negative number. Why -2? I could have multiplied by any negative number. I just chose something nice and small. So now I end up with this. Is that a true statement or a false statement? False. It's false. The only way to make that a true statement is to flip the inequality symbol. So that's a false statement. But if I take that same statement with -16 and +6 and I instead flip the inequality, it's now a true statement. Same thing with dividing. If I take this true statement and if I divide it by any negative number, I chose -2 because it's nice and small, I now have a false statement. I had a true statement, it's now false, but if I take that false statement and flip the inequality from greater than to less than, I now have a true statement. And so that proves that's what's really happening. Anytime we multiply or divide by a negative number, we must flip the inequality symbol. So we're going to do a few of these together, and then I'll have you try some on your own. When we are solving inequalities, we solve them the same way that we solve equations. In other words, in this one, we should divide both sides by 5. Let's write that down, please. Now the difference is the solution is not k equals something. It is k is less than something. So the solution should be k is less than 6. Now, I divided by a positive number. How do I know that? This is why I consistently show things in different colored font. I divided by a +5. Therefore, I should not flip that inequality symbol. So the solution is k is less than 6, and we need to quickly graph that. And the graphing is the same as the graphing was for everything else that we've done. Open circle over 6. All the numbers that are less than 6 are all to the left of 6, and so we would draw an arrow to the left. Okay, let's go to number 2. X over 7 is greater than or equal to -8. How would I go about trying to solve this one? And did you multiply both sides by a +7 or a -7? Yeah, and that's the key right there. Since we multiply both sides by a +7, we do not do any flipping of the inequality symbol. So the solution is k is greater than or equal to, remember we did not flip, we do not flip because we multiplied by a positive number. Solution is x is greater than or equal to -56. Let's quickly graph that. Open or close circle? Close. Would the arrow be going to the left or to the right? Right. To the right. We're talking about all the numbers that are greater than -56 are all on the right-hand side. So we draw our arrow to the right. Okay, I want everybody to please do number 3 and number 4. Do both of them, please. All right, reality is you should know before you even start solving whether you are going to have to flip the inequality symbol or not. Even when we get to 2-step inequalities tomorrow. Because that very last step that you do, when you look at this problem right here, it should be obvious to you that you have to divide both sides by 2. 2 is a +2. So we do not flip in this one. It doesn't matter that there's that -10 right there. And that is the most common mistake. Some people think, hey, I see a negative number right there. Therefore, I flip. The rule doesn't say if you see a negative number, you flip the inequality symbol. The rule says if you multiply or divide by a negative number. we are dividing by a positive 2 here. Therefore, we do not flip the inequality symbol. So the solution is k is less than or equal to negative 5. Graph, closed circle over negative 5. All the numbers that are less than negative 5 are to the left of negative 5 on a number line, so that's what the graph looks like. Number 4, we have to multiply both sides by a positive 3. Therefore, we do not flip the inequality symbol. We end up with r is less than negative 18 as the solution. Once again, the idea of flipping has nothing to do whether that's negative, has nothing to do whether that's negative. It's what you did right here, which in this case we multiplied by a positive number. So the graph is going to look like this. Open circle over negative 18. All the numbers that are less than negative 18 are to the left of negative 18. All right. Everybody do number 5, 6, and 7. All right. One of the things that I want to change a little bit about the shoulder partnering process is normally what I say to you is I say this. Figure out who's right and help each other out and why. But I want to change it slightly, and I want to change it to this. If you two agree with each other, then whoever is sharing, you could just simply state, I agree with your solution. But if you disagree, I want you to state it like this. I disagree because maybe you didn't flip the inequality symbol. Or I disagree because you were supposed to have a closed circle over the number instead of an open circle. Do all of you understand what I'm talking about? Just changing slightly what we're doing there. All right, number 5. We divide both sides by negative 2. Since we divided by a negative number, we must flip the inequality symbol. So the solution is k is less than negative 8. Graph would look like this. Number 6, we have to multiply both sides by a negative number, specifically negative 5. That means we have to flip the inequality symbol. That would give us a solution of x is greater than or equal to negative 50. The graph would look like this. Number 7, we divide both sides by a positive 4. It has nothing to do with that negative 12 as far as the flipping. So therefore, we do not flip in this one. The solution is k is less than negative 3. Graph looks like this. All right. This is what number 8 looks like. So we have to stop for a second so that I can explain how we deal with the remotes as far as typing in a numeric answer. So listen carefully. We have no way of inputting a less than or greater than or less than or equal to or greater than or equal to symbol. So in situations like this, what I will do is I will have you solve this. Okay? And then you're going to input the numerical part of your answer. So like let's just say you got 1,000. It's not 1,000 obviously. Okay? But if you got 1,000, then you would take your remote, type in 1,000 with the numbers, and then click OK. Everybody got that? Yeah. All right. So I want you to go ahead and solve it. And then when I tell you to, then you can turn on your remote and input the answer that you get. But go ahead and solve. I'm not asking you to graph, only to solve. All right. So in this inequality, we should have divided both sides by negative 10. Since we divided by a negative number, we have to flip the inequality symbol. So the solution is k is greater than 7. All right, let's go to number 9. Same idea as the inputting. All right, in this inequality, we need to multiply both sides by negative 8. Since we multiplied by a negative number, anytime you multiply or divide by a negative number, you must reverse the inequality symbol so that it will be a true statement. So the solution is t is less than or equal to negative 16. Number 10. Number 10 is the easiest out of all of them. But if I don't at least quickly remind you of something, it will be the most missed kind of problem. And we have dealt with variables without a number in front. So when a variable does not have a number out front, there really is a number out front. And what is it? 1. But in this one, it will be negative 1. So don't forget that. Now, go ahead and solve. We obviously have to divide both sides by negative 1. And since we divided by a negative number, Anytime we multiply or divide by a negative number, we must flip the inequality symbol so that we have a true statement. So the solution is n is greater than negative 11. All right, so let's put the remotes down for a minute. We're going to do a couple of problems and then we'll come back to them. Now the language objective part of our lesson. Remember, this is now the third time we've gone back to different word phrases that mean is less than, is greater than, is less than or equal to, or is greater than or equal to. So here's what you're going to do. You're going to translate number 11 to an inequality. I don't want you to solve it. All I want you to do is to translate that to an inequality, and then we're going to talk about whether we need to flip the inequality symbol or not if we were asked to solve it. Go ahead and give it a shot. All right, the inequality that we could use to represent that sentence would be 7t. I saw a few of you had t7. Remember, we like to write the number in front of the variable if we're multiplying. Question for all of you. If I asked you to solve that, would we have to flip the inequality symbol?
No.
No, because we would have to divide by a positive number, and that would mean we don't flip it. All right, we're going to do the same exact thing for number 12. Go ahead and try number 12. The 2's will take this one. I want to hear I agree or I disagree when you exchange answers. So we've got an issue here. This is what I saw. A few of you missed that it said divided by right there. And so we tend to write division as something that looks like a fraction. So this one should have been b over negative 4 is greater than or equal to 3. If I asked you to solve this one, will you be flipping, yes or no?
Yes.
Yes, you will, because we had to multiply by a negative number. All right, so now we can pick the remotes up again. We had several problems like this last lesson, so now we're inputting the correct answer via a letter, whether A, B, C, or D. You need to solve both of them first. So I'm not even turning this one on until I know everybody has worked both of them out. You need to work both of them out before you can make that decision. The correct answer is for this one. You think it is B. All right, let's try that out really quickly. For A, you have to divide both sides by negative 3. Since I divided by a negative number, I have to reverse the inequality symbol. And that makes this one not the same thing as what we were trying to make. In letter B, I subtract 4 from both sides. I don't have to flip in this one, so this is what I was trying to make. Therefore, the correct answer is B. Inequality B is the only one that had that as the answer. All right, let's do the same thing for number 14, and then we're finished.